The next subsurface investigation method is known as ground penetrating radar method, popularly known as GPR method. This is again one of the easy method known as non-destructive geophysical method. The advantage is similar to electromagnetic method. Here we can also get continuous cross-sectional profile, right. About the subsurface, no drilling or probing or digging, mostly used to evaluate the location and depth of buried objects, especially the utilities, right. You would have also come across the use of ground penetrating radar along our major roadways, especially in cities. A company who wants to lay a telephone cable may pre-check whether there are any other utilities under the ground, right. Within near surface up to 1 or 2 meters can be precisely investigated by ground penetrating radar to come out with the utilities present below the surface. So, this investigate the presence and continuity of the natural subsurface formations also, right. Not only utilities, but also to understand the subsurface, we can rely on the ground penetrating radar. So, what is ground penetrating radar? What it does? What is the principle? Here we have two antenna, one to transmit, one to receive, right. That means we have a transmitting antenna and a receiver, similar to electromagnetic methods. What we do here is we generate some impulses of radar waves, which are nothing but electromagnetic waves. These waves, which are nothing but radio waves, these pulses are generated in different frequencies, right. We have different frequencies, antennas capable of transmitting the signals in different frequencies are available. We are going to see a little later. So, these signals, transmitted signals, are focused onto the ground, right. The changes in the properties of the subsurface, especially the dielectric properties of the subsurface, right, affect the signals. Here you can see the signals are transmitted, and when it meets certain interface, it gets reflected back. Part of the waves go past the interface, meet the next interface, gets reflected. Part of the signals goes much below, and they are getting reflected back to the surface, which are received. Using this technique, here you can see we are able to demarcate the interface between the, for example, this is an unsaturated soil, saturated soil, beneath that is a impermeable formation, impermeable, right, maybe a bedrock. We are able to differentiate, but the limitation of this method is we can understand about the shallow subsurface. Depth of exploration is soil dependent, right. Suppose if you have dry sand, we can go up to a maximum of about 30 meter beneath the surface, but if you have clay right at the surface, saturated clay, depth of penetration can be only few meters, maximum of 3 meters. That is the disadvantage of this method, right. Here, with a little more detail, we are seeing the transmitted signal enters into the ground, right, and contacts the subsurface strata, maybe a bedding plane or some other contacts. So, here you can see our scholars in the field near Madurai using the ground penetrating radar. We have one transmitter and a receiver, and which are connected to a recording unit, wherein we can simultaneously see the image, right. So, part of the radar waves reflect off the interface or any other object present below the surface, right. There may be object that may also reflect the signals, and part of the waves pass through to the next interface. the reflected signals from different interfaces return back to the receiver antenna, right, which also is transmitted to a digital control unit which is held by him, right, a digital control unit. The control unit records the reflections against time, right, that means against two-way time, right. This is the transmission, the waves got reflected back and the arrival times are recorded. Similarly, here from several objects and interfaces, the waves are getting reflected back. So, it measures the time in nanoseconds, right. The output of this is shown here, right. The output signal peaks are plotted in different color bands by the digital control unit, right. Some control GPRs has got a display. Some, as we carry out the survey in the field, we will be able to see the display. Some of them have to, in some of the models, we have to download the data using the software provided. We will be able to bring out this diagram, right. So, here we have a kind of color bands of radar signals. Here too, the top is the surface radar waves which are considered as a noise. Only from here is the ground surface. These color bands indicate the presence of different subsurface layers. Here fortunately, we have interpreted them as dry sand, sandy, clay, right, wet sand. So, this is how we have interpreted side by side. We had also drilled a small borehole. We have also cross checked our interpretation with that, right. So, here are some additional information with regard to the antenna and the frequency, and as I told you, it is completely non-invasive, right. We just keep the antenna on the surface like electromagnetic method, not even a hole is made, right. It provides information up to 12 to 15 meters, sometimes up to 30 meters maximum, depending upon the frequency of the antenna which we use, as well as the property of the soil, right. Especially if you have completely wet clay, then the these radar waves won't be able to penetrate them, right. Only up to few meters we will be able to understand. So, commercially available ground penetrating radars has got transmitters in the range of 50 megahertz to 1000 megahertz, right. Here too, we are carrying out the investigation near Madurai. We will see the results little later, right. And beneath the surface, the transmitted signals are meeting the different interfaces and returns to the ground surface, right. And with regard to the frequencies, we had just now seen it is available in 50 to 1000 megahertz. If we use a low frequency antenna, it provides better penetration but poor resolution, right. That means low frequency antennas, for example, if you use a 50 megahertz antenna, transmitting antenna, we will be able to achieve greater depth of penetration, maybe up to 25-30 meters. But the resolution which we will get will be poorer. We will have a poor resolution. Whereas, high frequency antennas give poor penetration, that means only up to shallow investigation, but we get good resolution, right. This is the lacuna of the GPR methods, especially to understand the near surface man-made objects. It is very vital. This method is very useful, wherein we use high frequency antenna, we get a high resolution shallow image, shallow up to 2-3 meters, right. And there are many critical environmental monitoring situations, right. In certain situations, GPR does not provide the depth of penetration, especially as I have been telling you, depending upon the conditions prevailing at the near the surface. we may not be able to get adequate information using GPR, or we may not be able to get adequate resolution. Why? When you use low frequency, the depth of penetration is more, but the resolution is poor. When you use high resolution antenna, our investigation is restricted to very shallow subsurface, only few meters. Right? To overcome these issues, today we also have borehole radar methods. That means the radar can be kept taken down the borehole, so that we keep the radar as well as sensor closer to the region of interest, which region we have to investigate. So, this will help us to overcome the issue which we discussed here, right. And here you see another model of ground penetrating radar. Here both transmitter as well as receiver are attached just beneath the small trolley, right. You have the transmitter as well as the receiver, and the signals are sent to the recording unit, where you also see a display. Directly you see the display of the subsurface image, right. This is another model which is very handy, right. You can just push this cart. As you push this cart, you get the continuous image of the subsurface, right. And here are some results of ground penetrating radar. Here in this example, they have used ground penetrating radar to bring out the underground utilities, right. This is the cross section which we have monitored, right. Perpendicular to that, there are several utilities passing through. This is what I was mentioning previously. On the sides of the roads, we may have to dig, or we may have to dig across the road to provide some connectivity, to check what are all the utilities that are running across or running beneath the surface parallel to the road. So, this is a road. There can be several utilities under that. As you can see here, there are some communication cables, gas pipeline, sewer network, some electrical lines, water pipelines. There are many such utilities are beneath the ground surface. When you want to dig the road, without knowing this, we may damage them, right. So, quickly we will get to know of their location by ground penetrating radar. So, here you can see this ground penetrating radar has picked out all these locations, right. This is here. Similarly, these are the electric as well as this cable. So, this is also seen indicated here, this one is indicated here, this sewer line is indicated here, right. So, this is how ground penetrating radar is very useful to locate the underground utilities, as you can see in this picture, right. And the next result is more or less on the same lines. Here too, the ground penetrating radar has been used at the surface of the earth to locate the buried metal tanks, right. There were several metal tanks present below this area. They could be very clearly brought out by the ground penetrating radar. Also, presence of some pipes, right. The presence of pipes can also be brought out by the ground penetrating radar survey carried out over the surface. And here are some of the work carried out by us. Though the signals are little bit distorted, here we could decipher some anomalous body present below the surface of the earth. This survey was carried out near a major city in southern India, in Tamil Nadu, very close to Madurai, with the focus on understanding some buried artifacts below this terrain adjacent to a important river known as Vaigai river in Tamil Nadu. So, here again we are carrying out the investigation at the surface using the ground penetrating radar, right. The recording unit is held by this person. You have the transmitter as well as the receiver, right. And as I told you, the presence of some very fine grained material at the top did not give excellent signals, right? Anyhow, this is a raw data which is shown here, and here again at the same site, at this packet there seems to be some anomalous material present below the surface. It is a sedimentary region which you can understand from this picture, right? This all of them are mostly sand or fine sand or clayey sand, right? So, in another survey which was carried out near Chennai, this is the ground penetrating radar image obtained very close to the city of Chennai, just north of the city of Chennai, right? Using the ground penetrating radar, we could understand the stratigraphic variation. With the borehole drilled adjacent to this location, we could also arrive at the lithological log, which reasonably compares with the cross section arrived from the ground penetrating radar. Here in this diagram, we have a look into the crop. So, here I am showcasing how we had successfully used ground penetrating radar to understand the subsurface behind two managed aquifer recharge structures, right? Managed aquifer recharge structures are structures made intentionally to harvest the rainwater and make them to percolate below the ground to augment the groundwater resources, right? So, we did use the ground penetrating radar to identify a ideal site to locate a check dam in a major river running north of the city of Chennai, right? At different locations, we carried out the ground penetrating radar to demarcate the formations below the surface of the earth. In order to have the managed aquifer recharge structure, we need to have coarse sand closer to the surface, right, which will allow more water to infiltrate beneath the surface of the earth. In order to delineate the presence of layers below the surface of the earth, we have deployed the ground penetrating radar to understand the subsurface formations. If the subsurface has got clay very close to the ground, then the radar waves won't be able to enter to greater depth. Whereas here you can see we could decipher the different formations up to the depth of penetration of radar waves, which was about 10 meters, right? We had used mid-range frequency antenna. Since our focus is, we know here the water table is very shallow, about 10 to 15 meters. It is a river alluvium. So, our focus is to see whether the alluvial deposit has got any thin or thick layer of clay very close to the surface. Such sites are not an ideal site for managed aquifer recharge. Here we were planning for a check dam, right? So, ground penetrating radar was efficiently used to understand the subsurface formations. In another study, we wanted to dig a percolation pond as a method or as a measure of managed aquifer recharge. In order to select an ideal site for percolation pond, we had used ground penetrating radar. So, these are the signals collected from different directions, right? Different directions, right? There are two signals. This is the raw data. It's a processed data. This is the interpreted subsurface cross section, right? We have not taken into account of all the minute variations in the subsurface. Some major contacts or deflection objects are alone indicated in this diagram. So, this is how we could arrive at the subsurface cross section from ground penetrating radar. So, these are the applications of ground penetrating radar to understand the variation in the ground surface. And in another study, we had deployed ground penetrating radar along with my colleague Dr. Lenin Kalyanasundaram from Anna University. We are using a radar system which is mounted on a tricycle with the antenna at the bottom as well as receiver just adjacent to that, which is transmitting the signal into the ground, and as we push this tricycle, we are able to continuously study a particular cross section. So, this study was carried out to understand whether any buried artifacts or idols are present below the surface of the earth. So, this study could identify the presence of some buried pillars below the surface of the earth. So, this is the another application of ground penetrating radar. So, as you can see, ground penetrating radar is very fast, very rapid, because when you utilize this tool at the site, quickly we are able to see the subsurface. So, this is how we can understand about the presence of various, especially man-made objects, can be very clearly brought out by the ground penetrating radar. Also, the discontinuities in the rocks below the surface can be brought out to some extent under favorable conditions. These are all the applications of ground penetrating radar. Thank you very much.